Hello everybody, this is Alexey Kavazin, President of Firebird Foundation, and today I would like to discuss InlineSortThreshold, a parameter from Firebird configuration file which is very important for queries with sortings. We will see why InlineSortThreshold is so important, how it works, and how to tune it to achieve better performance for queries with large sortings like reports. In order to understand why InlineSortThreshold is important, we need to start with some basic theory. As you know, there are operations which require sorting, like order by, group by, distinct, and union, without not union all. So if we will take a look on this very simple example, sorting means that we are receiving some record set and sort it using some criteria. For example, in this query we have record set ID and name, and it is sorted by date 1, some field which contains date. How it works normally? Depending on the database structure and the query, Firebird can select a different approach how to sort the data. In general, we have record set, ID and name, and sort key. In this case, is date 1. And we can say that we don't know how the Firebird will sort it. In order to see how Firebird actually performs the operation, we need to take a look on SQL plan. And inside this SQL plan, we will see one of the three keywords: sort, refetch, or index, which are specifically the ways how Firebird sorts the data. Let's see how works the first and the standard way sort. So when you see in the SQL plan sort, it means the following. So Firebird should get the fields from select, in this case it's ID and name, add to them the key of sorting, in this case date, and form a line, a record to be sorted. In this example, for example, we have ID, it's 8 bytes, name, let's say it will be varchar 100 with some ANSI char set, and date, also 8 bytes. So totally it's 116 bytes. Firebird does sorting in three following steps. First of all, it fetches the data, both data from select clause and key, into the single wide record set. Firebird unites data which should be returned into the united record set, and after that the second step is actually order it and then start to return these sorted records, results, to the user, to the original invoker of the SQL query with sorting. Let's consider the situation when we have put into the select clause not the list of fields like ID and name, but we just put the asterisk to extract all fields from this table. If this table is pretty large, for example, the sum of lengths of all fields is 20,000 bytes. In theory, it could be up to 64 kilobytes. It means that the total size of the record to be sorted for the sort operation will be, in this example, 20,008 bytes. If we have a query like ID, name, date with specified list of columns to be sorted, it will generate, let's say, record set 1 gigabyte, pretty large. And this record set will fit into the temp cache limit. For example, if we are on 2.5, temp cache limit is 2 gigabytes, and yes, we are inside the limit. All operations are being performed in memory in the fast way. However, if we put asterisk to the query, and in this situation the record to be sorted will become really wide, it is possible that record set will be much higher. For example, in this example, it is enough to have 3 gigabyte record set, or let's say more than 2 gigabytes. So it will be more than temp cache limit. And if it is more than temp cache limit, the Firebird will put rest of the data to be sorted on the disk and start to perform sorting on the disk. And this sorting, of course, will be much slower than the sorting in memory. So this is a direct way to slow down the order by, group by, and other sorting operations. So the obvious question, how we can see the size of sorting, and if it is so important and if it can impact the performance of the query with sorting, we need somehow to see the sizes. And yes, Firebird allow us to see the size of the sorting in explained plan or directly in SQL or in other tools, or in trace, if you have set the explain plain option to true. Example of the set explain plan. Let's imagine that we will do the really simple query to the system table RDB types. This table RDB types contains a list of all types used by Firebird. So we just took it as an example because it contains char, small int, blob. So that's pretty good example for our purpose. Let's do this very simple select RDB type name from RDB types order by RDB type. If we have enabled set explain, we will see the following explained or detailed plan. Select expression, and you can see the record length 284 and key length is 8. And operation is full scan to read the table completely in order to perform this sorting. If we will put asterisk in our example, we will see the difference. You can see that record length to be sorted became 548, but key length remained 8. Let's see the details of record size calculation. Each record to be sorted inside this sorting record set will be always aligned to 32 bytes. However, it also has additional fields like transaction number, the key for DB key validity, DB key itself, and key for the record set. In this situation, we can calculate how much data returned, why these data correspond to this record length. As you can see, the character is 63. However, because it is UTF, it is multiplied by 3. So this record length, of course, depends on the char set which you are using. So we have this record site calculation, and we can easily see in the result, in the explained plan, what will be our record to be sorted. Let's imagine that we have 1 million records to be sorted. With 548 bytes, it will be like 522 megabytes. However, if we will imagine that we have a table with varchar equal to 1000 bytes and integer, and we will try to perform this sort, like in this example, select all from T1 order by I1. Roughly, it will mean that each record will be like 4 kilobytes. 4 kilobytes. So 1 million record in this example will easily become 3.7 gigabytes. Now let's consider the following example. When we have a query which sorts a lot of data but returns only a fraction of this data. In this example, you can see that table T1 consists of 1 million records. Each record is 4 kilobytes. The size of key field F1 is 8 bytes. When Firebird uses the plan sort, it is necessary to sort all 1 million records, so totally 4 gigabytes, but size of data to return is only 40 kilobytes, because we ask Firebird to limit the record set only to first 10 bytes. Anyway, of course, in order to return these 10 records, Firebird requires to sort 1 million records. How we can improve it? The answer is Refetch. Refetch is a plan which appeared in HQBird 3, and after that it appeared in Firebird 4, was ported to Firebird 4 with another parameter name, InlineSortThreshold. The idea of Refetch is the following. If optimizer sees that record to sort is bigger than the specified limit, it will sort only keys and reread records by the key. So in our example, it will sort only key field, and it will be much faster. Let's return to the example of the refetch. Let's, for the testing purposes, create a table, test11, which contains the integer and very big varchar, or 20,000 records. And let's do the select from test11 order by I1. You can see in the explained plan that we have refetch, plan refetch, and the sort is much smaller than it was. Record length is only 28 bytes and key length is 8 bytes. How it works? The difference is the following. First of all, refetch read records and build keys for record set. It sorts keys and the pointer to the record You can notice with in the explanation that key length is 8 bytes, but the record length to sort is still 28 bytes, because anyway we need to have pointers to the all records which are in the select clause. So after ordering, it is pretty quick because the record set is much smaller in terms of memory, and it will fit into the temp cache limit. We are rereading records according to the sorted keys. So we extracted the keys, sorted them, and only after that we are reading the records and returning ordered results, ordered according to order by statement. And as you remember, in our example, in our test example, if we will limit like first 10 or something, first 10 records or first 100 records, the overall amount of data to be read and to be sorted is much, much smaller than with traditional sort parameter. So Refetch is really great tool to tune reports and receive better performance for ordering, grouping, distinct, and so on. However, for the situation which I described, the first, many developers could say, okay, but we can also use the index for the sorting. Right. If there is an index matching the condition in order by or group by, Firebird will try to use index to sort data and return them. And in this case, Firebird will not use temp cache limit. It will not use temp area to store records and do this life cycle of the traditional sort and more advanced refetch plans. However, of course, the order index, using the index for ordering, for sorting, has its limitations. Order index has its own limitations. First of all, order index, it is not possible for Firebird to use it if in the order by condition, in group by condition, there are fields from the different tables. If there are fields from different tables, there is no way to create index, no way to use index or combine indexes to access data from several tables. Also, when it is necessary to sort a lot of records, not like 10 records like it was an example, sort and return, it is necessary to remember that accessing data through index requires 3 or even 4 times more fetches operations than the natural scan of all records. Because every time when the Firebird accesses data through index, it performs reading of index pages, it jumping through the level of index until the leaf, and after that jumps to the data page. In case of sort operation, if it is done through the natural plan, it will just read all data pages to the memory and do the sorting of key fields. And it is really could be much faster. So I made a table to compare these 3 methods from the practical point of view. So the sort, refetch, and index. As you can see, sort and refetch, they use the temp area. They use the area defined by temp cache limit. Index does not use it. Sort fetches record and key. Refetch, no, only key. Index also access data through the keys. Is it good to sort millions of records with small or moderate size of the record? sort yes will do fine. Refetch depends on the situation, but in general, if we are returning only fraction of the sorted record set, yes, it will be really good. And index, no, it will be slower than the sort. If we need to sort millions of records with extra large size, refetch will be really better, because if the records to be sorted like 16 kilobytes or even more, and the size of the sort file in the traditional sort way will be like 16 gigabytes, 32 gigabytes or even more, refetch on majority of hardware configurations will be fast. And index, no. Order index simply does not good for sorting and returning of a lot of records. Because index, yes, it is pre-sorted, so you just accessing it. But if you need to access like all the table, it will be slower than sort the table and do the thing. So is it good to return only a few number of first rows? Sort, no. Refetch depends, and index, yes, it's the best way. Order group condition can have columns, fields from various tables. Sort, yes. Refetch, yes. Index, no. And of course, we need to remember that the refetch actually will read tables twice. The first to extract the key fields, and after that extract the data for the select clause. So there are some practical recommendations for tuning inline sort threshold. It's pretty simple. You just need to find queries with sort plan, which generates large sort files, and try to set inline sort threshold less than their record length. You will identify the record length by the plan in the output from the trace. If you will set explain true. And after that, you need to monitor production to see if these queries will be faster and if it will not affect other queries, because this inline sort threshold will will be applied to all sorting operations. In general, if you know, for example, if you are building some reporting application, or you have put the data to the replica server, where we will be treated mostly as a source for reports, it is good to set inline sort threshold to some smaller value. And instead of reading all the data and sorting wide record sets, you will be only sorting small record set, and after that reread data. On the production servers, it is more difficult to find the the balance, the good ratio for inline sort threshold. But again, it is possible if you know how the inline sort threshold works, and if you are you are monitoring the queries with sortings. In order to analyze the actual temp space usage and identify the queries, champions which use a lot of temp space, in HQBird we have the special parameter temp space threshold, which is not yet ported to Firebird Vanilla, but I think it will appear in some of the next version, some of the future versions. And with this parameter, it is really easy to set the threshold and see how the queries actually use and allocate temp cache limit memory. And with this information in hand, it is much easier to decide what inline sort threshold parameter really needed. The size that you can try, for example, set bigger or set smaller, and optimize your reports in this way. So thank you very much for watching this video. So please send your questions, your feedback to my email, and see you soon. Stay tuned for the next episode.